So today we've been asked to solve three equations, and each of these equations happen to have a variable in the denominator, and you'll see question 1 there, 5 over 3x plus 2 equals 3 over 2x. And anytime you have a variable in the denominator, there's question 2, and then there's question 3. These are called rational equations, which is just a fancy math way to say fractions, but without scaring you by saying fractions. So anyway, we've been asked to solve these, and there are lots of ways to solve these, but I have always found the simplest and easiest way to solve a rational equation is to multiply every term in the equation by the least common denominator. Okay, so multiply by the LCD. Now, you have to know why you're doing this. The reason you're doing this is if you multiply each term by the LCD, then the denominator terms in each term will cancel out with part of or all of the LCD that you multiplied by. And the reason for that, very simply, is that it gets rid of the fractions, and it makes this equation something that has only linear terms or quadratic terms without having to deal with all the denominators and the common denominators and all of that fun stuff. So the first step, obviously, for any problem like this is to find the LCD. Well, in this case, these two LCDs, these denominators have nothing in common. So the LCD is just simply 2x times 3x plus 2. Okay, that's our LCD. So we're going to multiply each term by our LCD. And I like to use a different color pen when I'm multiplying by the LCD so that I can kind of see what I did. So I'm going to write that in there. So times 2x times 3x plus 2 times 2x times 3x plus 2. Now, what's going to happen here, very simply, is that because I have multiplication on top, so 5 times 2x times 3x plus 2, I have multiplication on top. And I have multiplication on bottom because you can think of this as 1 times 3x plus 2. The 3x plus 2's will cancel. Same thing here. I've got 2x on top, I've got 2x on bottom, and these will cancel. What am I left with? I'm left with 5 times 2x. Well, 5 times 2x is just 10x. Here I'm left with 3 times 3x plus 2. Well, this is going to distribute, and it's going to give me 9x plus 6. And I look at this and I say, wait a minute. I went from this complicated equation to 10x equals 9x plus 6. Yes, you did. And that's the reason I like this method, is because it at least simplifies somewhat what you've got to do. However, you have to find the LCD first. So I'm going to subtract 9x from both sides, and 10x minus 9x is 1x. And that's going to leave me a very simple answer of x equals 6. And if someone asked you to check your answer, you could check your answer, which would be 5 over. Now, 3 times 6 is 18. 18 plus 2 is 20. So you get 5 over 20 equal to. And over here you get 3 over 2x. Well, 2 times 6 is 12. So you get 3 over 12. Okay? And the question is 5 over 20 equal to 3 over 12? Well, 5 over 20, if you reduce it, is 1/4. And 3 over 12, if you reduce that, is also 1/4. And so if that's true, then we know our original solution is also true. So it's a quick, easy way to check your answer there. Now, let's move on to problem number 2. Problem number 2, instead of having 2 fractions, this time has 3 fractions. And the first step, when you have especially something like this, is to factor your denominators. And so I'm going to take this 3x plus 6 is the same as 3 times x plus 2. Okay? And x squared minus 4 is x plus 2 times x minus 2. And x minus 2 can't be factored, so we're just going to leave that as x minus 2. Okay? So those are our denominators in factored form. Now, hopefully somewhere along the line someone taught you how to find a least common denominator. However, I'm going to review that very quickly here. And the way we find the least common denominator is very simple. We prime factor each denominator, which we've done. And then, if we have a term that is the same in two denominators, like x plus 2 and x plus 2, it is only written down one time in our LCD. So we're going to write x plus 2 once, because it's shared by two fractions. We're going to write x minus 2 once, because it's shared by two fractions. And then we're going to write down the 3. So our LCD for this problem is 3 times x plus 2, x minus 2. Okay, there's our LCD. So I want to multiply each fraction by that LCD. So I'm going to multiply this fraction by 3, x plus 2, x minus 2. I'm going to multiply this fraction by 3, x plus 2, x minus 2. I'm going to multiply this fraction by 3, x plus 2, x minus 2. Okay, so there's all my, it doesn't even quite all fit in the camera view there, so to zoom out just a smidgen. Okay, now, what are we going to do next? Well, let's see what we've got left over. Now you've got to remember, 3x plus 6 is the same as that, 3x plus 2, 3 times x plus 2. So that and that are going to cancel out. X squared minus 4 is the same as x plus 2x minus 2, so they're going to cancel out. And then here, x minus 2 and x minus 2 will cancel out. So what's left? Well, I've got 1 times x minus 2, so I'm going to get x minus 2 minus 1 times 3, which is just 3, equals, and then here 3 times x plus 2. So, well, 3 times 3 is 9, and 9 times x plus 2 is 9x plus 18. Okay? So I end up with x minus 2 minus 3 equals 9x plus 18. So I'm going to write that a little differently. Can I combine like terms here? I've got minus 2 and minus 3, and minus 2 minus 3 is minus 5. So I get x minus 5 equals 9x plus 18. And boy, that's a pretty easy equation to solve compared to what I was given. So I'm going to move the x over to the right. Well, 9x minus x is 8x. And I'm going to move the 18 over to the left. So negative 5 minus 18 is going to end up giving me negative 23. Okay, so 8x equals negative 23. And if I divide both sides by 8, I get x equals negative 23 over 8. So that's what I get. And the big problem with rational equations a lot of times is we get these ugly answers. And of course, to plug that into the original equation, 1 over 3x plus 6 minus 1 over x squared minus 4 would be really difficult. Okay, would be really, really difficult. However, there are some ways to do this using different technology. And one way that you could do this using, say, like a graphing calculator is you could type in 1 over 3 times negative 23 over 8 plus 6 minus 1 over, and you could type that in and then get an answer, and then type this in and get an answer and see if they're equal. The problem is that you're more likely to make a typo typing all of that in than you are to just trust your answer here. So I'd like to just leave that and not worry about checking it, although you know, it would be a good idea if you had time, but this is a rather difficult one to check. So anyway, how about number 3? So number 3 says 1 over x plus 2 over x plus 1 equals negative 3 over x plus 2. So what do? Well, we've got to find our LCD first. So we factor these. Well, do these factor? None of these factor. Well, if they don't factor, then the LCD just has to be these three denominators together. So it's x, x plus 1, x plus 2. That's your common denominator. So I'm going to multiply each fraction by the common denominator and see what we get. So here I'm going to multiply by x, x plus 1, x plus 2. Here I'm going to multiply by x, x plus 1, x plus 2. Here I'm going to multiply by x, x plus 1, x plus 2. The x plus 2's cancel, the x plus 1's cancel, and the x's cancel. So here I'm left with x plus 1 times x plus 2 plus 2 times x plus 2 equals negative 3 times x plus 1. Okay, so I'm left with a little messier situation than the first two problems. But certainly nothing so ugly as what I started with. So basically I need to multiply each of these statements out. Okay, so I need to multiply each of these statements out. So I start with this one. I have x plus 1 times x plus 2, which gives me x squared plus 3x plus 2 plus, and here we're going to have 2 times x is 2x, and we're going to distribute that, so we get 2x squared plus 4x, and then here negative 3 times x is negative 3x, and we're going to distribute that, and we get negative 3x squared minus 3x. And basically at this point what we should do is we should combine our like terms, and we notice, what do we have? We have a quadratic. You've got an x squared term there, an x squared term there, and an x squared term there. So we should combine, we have a quadratic, and quadratic should be set equal to 0. So I'm going to move everything to the left-hand side and combine like terms. So I'm just combining like for terms first. So x squared plus 2x squared makes 3x squared, and 3x and 4x make 7x, and then the plus 2 we're just going to tack on to the end, negative 3x squared minus 3x. Add 3x squared to both sides, we get 6x squared. Add 3x to both sides, we get 10x. And so we get 6x squared plus 10x plus 2 equals 0. And you can try to factor this, and the first thing I notice is that 2 will go into all of these things. So I factor out a 2, and I'm left with 3x squared plus 5x plus 1. And 3 is a factor of 3 and 1, and factors of 1 are 1 and 1. And 3 times 1 is 3, and 1 times 1 is 1, and 3 plus 1 makes 4, not 5. And this doesn't factor. Well, if it doesn't factor, we have to use the quadratic formula. This is A, this is B, and this is C. So I come over here and I say, okay, the opposite of B, plus or minus B squared, which is 25, minus, now 4 times 3 times 1, 4AC. So 4 times 3 times 1, well 4 times 3 is 12, and 12 times 1 is still 12, so it's minus 12 over 2A. So 2 times 3 is 6. So there's the quadratic formula, and 25 minus 12 is 13, so I get negative 5 plus or minus the square root of 13 over 6. And since 13 is a prime number, there's no way to reduce this radical. So there's nothing else I can do. And so here are my two solutions. I have two solutions to this. And what we should do in this particular instance is plug these solutions in and see if they work. And again, there's a couple of different ways to do that. Now, obviously, the most difficult way to do this, the ugliest way to do this, I guess, if you will, is to type, negative 5 plus the square root of 13 over 6 and get a decimal negative 5 minus the square root of 13 over 6 and get a decimal. Now, I want to show you a simple way to check these with a graphing calculator. And I have here a TI-84 Plus. And I want to go back to this negative 23 over 8. And just very quickly, the first thing I want to do is type in 23 divided by 8. And I get 2.875. And so I want to jot that down in 2.875. So 2.875, okay? And that's going to become important to me. Specifically, it's a negative 2.875. And I'm going to go back to my original equation. Okay, my original equation was 1 over 3x plus 6. Now, I want to show you something. If I take my calculator, okay, if I take my calculator and I type in to y1 the original equation set equal to 0. Now, to set it equal to 0, you're going to have to move this term to the left-hand side. Okay, so I'm going to type this in. It's going to be 1 divided by 3x plus 6 minus 1 over x squared minus 4 minus, because I'm going to move this to the left-hand side, 3 over x minus 2. And I'm going to graph this. And this equation is going to have a solution, okay? It's going to have a solution where it strikes the x-axis, okay? Any equation that you ever want to check is going to have a solution where it hits the x-axis. So I'm looking at the x-axis, and I'm looking for a number around negative 3, right? This is equivalent to almost negative 3. So I look at my x-axis and I say, well, I don't know. That looks like it might be right. It might be wrong. I don't know. So what can I do? Well, I can go to the Calculate menu. Okay, it's right above the Trace button. And I'm looking for 0. 0 is another way to say a solution to an equation. So you click 0. And it's going to ask you a few questions. It's going to ask you for a left bound, a right bound, and a guess. So I try the left bound, and I try the right bound, and I hit a wrong key. So let's go back to my graph. Let's go back to my Calculate menu, and I'm going to type left bound. It asks for a left bound. So you go to the left of that point, a right bound, you go to the right of that point, and then a guess, you go somewhere near that point, and it says x equals negative 1.3, y equals 0. Okay, and so either A, I typed it into y equals wrong, or B, and you know, it could be either. B, I've got a wrong answer. So one of the things I'm going to tell you you need to learn to do is to put lots and lots and lots of parentheses. And I see where there's a problem. And I see where that would cause us an issue. So I'm going to graph this again. And hopefully this time I have something. And if you look here again, now this time, you see all I did was put parentheses in. And you have to be very, very careful how you enter things on this calculator. And by putting the parentheses in, I get a very different picture. And this is the reason I don't like using this method, but at the same time, it's a very useful method if you get used to typing things in. And this doesn't touch the x-axis. This obviously does not touch the x-axis. This is above the x-axis and then comes down. And I'm going to change my window just to show you that. I'm going to change my y max to 1. And you will see, let me change my y min to maybe negative 2 or something like that. And you'll see this quite well, actually. You'll see it goes through. And specifically, I'm looking at this and I say, look, it's negative 1, negative 2. It goes through right around negative 3. How do I check? Well, I go to the Calculate menu, go to 0, and I want the left bound. And I look and I don't see my cursor. And I don't see my cursor. And you see down here, it's telling you an x value. The x value is negative 2 point something. And all of a sudden your cursor pops on the screen. I need to go to the left of that point. So I hit enter. Now I need to go to the right of that point. I hit enter. And then I'm going to guess. So I go right there and I hit enter and I get negative 2.875, which was exactly what I said I should have gotten. So I know my answer is correct. Now let's move on to question number 3. How do we check that answer? Well, the first thing we need to do is to find out the decimal equivalent to these two numbers. So I take my calculator and I type negative 5 plus the square root of 13. And I always like to just hit enter and then divide by 6. And I get, and I'm going to write these down, negative 0.2324. And then I say negative 5 minus the square root of 13 divided by 6, and I get negative 1.434. Okay, so I get these two answers, and now I go to y equals and I type in the original equation. Well, the original equation was 1 over x plus 2 over x plus 1. Whoa, can't do that. That's what I meant to do. And then it was equal to negative 3 over x plus 2. Well, you're going to bring this to the left-hand side, which you're going to change the sign. So it's going to be plus 3 over x plus 2. And I'm going to hit graph. And of course, you know, who knows what I've got here. And I'm going to zoom back out. I'm going to just go to a standard window and show you what I've got here. So what do we see? We have this thing goes this way. A line cuts through the x-axis. Another line cuts through the x-axis. And then we have this thing goes off this way. Well, it looks to me like these two lines hit at you know, about negative 1.5 and at almost 0, and well, those look a whole lot like the numbers I had here. But I can check those again. Use the calculate menu. So I go to calculate 0, and I look here and I say, well, look, my cursor's right at this x-intercept. So I hit enter, right bound, enter, guess, enter. And I get negative 0.2324. Negative 0.2324. So I know that answer is correct. I go back to the calculate menu and 0. And I'm going to press to the left this time. And it'll switch to that line. Left bound. You've got to go to the left. You've got to go to the left of the line, and you're going to press enter. Then you click to the right of this x-intercept, and you press enter. And then you click as close as possible, and you press enter. That's your guess. And you get negative 1.434. Negative 1.434. And so we know that this solution is also correct. So this is a good way to solve, to check these solutions, and I've used this quite extensively in real life problems, because the worst thing you can do is hand your boss a wrong answer, and it's much easier to check it this way than it is to plug it into the equation, in my personal opinion. So anyway, the way to solve rational equations as well as to check your solutions. If you have any questions about this, please let me know.